Hey everybody, this is Larry. This is day 28 of the October LeetCode Daily Challenge. Wow, look at how much faster this thing loads. Let me know what you think about, hit the like button, the subscribe button, join me in Discord. But also let me know what you think about the font size and stuff like this. I'm still playing around because I'm on a new computer. I got the new MacBook Pro. I'm very happy about it. The battery life's good and things are fun, but I'm still trying to figure out the setup obviously because I was on an old setup for I don't know, 3, 4 years of streaming and videos or something like that. So yeah, now I'm trying to figure it out, and you could see me on high res or HD or whatever it is. But that said, I think the one thing that I am most interested about is the font size and whether it's clear. Also, I want to say that looking back my older YouTube videos, I'm like, wow, the resolution is kind of a little bit weaker. Guess you just don't notice it. But anyway, okay. Let's get started on today's problem. I usually solve these live, so it's a little bit slow, But this actually loads pretty fast now. Maybe my contest speed will improve by seconds. Shave some seconds on. Anyway, today's problem is sum. So given return all triplets so that okay. Let's see what is n is 3000. So okay. So I think 3000 is one of those borderline questions where okay, n cube is naive and clearly not good enough. N square 3000 square is going to be 9 million. We'll see. So that depends a little bit on input because at least on LeetCode, the time limit is based off the sum of all the time or the test cases. So it depends on how many test cases they give you, right? Like obviously, if they give you one test case, 3000 square is going to be good. If they give you 10,000 test case, then it's not, right? So there's some nuance there, but yeah. Can we go better than n square? I don't know that I can. So let's try the n square solution first, and then if it doesn't work, then we'll try something slower. Here we want to return, what are we returning? The actual triplets where I and j, and then we think out k. Okay. Let me think. Okay, I mean, the trivial thing is kind of, there are a couple of ways I can do it. So I'm thinking about it, right? So you can do, if you're doing an n square algorithm, you think about, say, n is equal to length of nums, and then you have for I is in range of in nums. Let's just actually do n, and then for j is in range from I plus 1 to n, and then you have some I plus j plus k is equal to 0, right? So that means that you have some num sub I plus num sub j plus some num sub k is equal to 0. And of course, if you rewrite this formula, you get num sub k is equal to negative of num sub I plus num sub j. So we're just trying to figure out this. The solution sum does not contain duplicate. Does that mean that, I think one thing this is not super clear about is maybe if we have like that, we would just not appear multiple times. Is that right? Whoops. Just want to get a clarification on what they meant by duplicate triplets. Is that on the result? If that's on the result, that should be fine too, but yeah. Okay, so yeah, so it should only appear once, but that's fine. Okay, in that case, yeah. So then we basically look this up and see if nums k is in the way. And of course, we can figure this out by there are a number of ways we can do this, right? What's a clean way that we want to do? I mean, we can basically have a lookup table or a hash table or something like that. And because in this case we don't care about duplicate triplets, then we don't have to return, like we don't like if there are multiple k's which they're all the same, we don't have to return them multiple times, so this should be good. So yeah, so then we just have to check whether this is in the array. Um, there are also a number of kind of tricky things about it, depending on how you want to do it, but should be okay. I think the tricky thing is that there are a lot of constant causes, but there still should be n squared no matter what you do, right? So as long as you have a lookup table, it's okay. So I'm gonna start with one way of doing it, and then maybe we'll tweak it around if it gets dicey. So for example, here we have, okay, so let's just say count is equal to collections of counter of num sub I plus 1. So this is basically the suffix, the count the suffix, and then for every j we do count of num sub j decrement. So then now we're just looking for num sub k, as we say is this. So num sub k is negative num sub I plus num sub j, and then if num sub k, if count of this is greater than 0, then we have a triplet, right? So then now we have a triplet of I, j, and k. We can actually do a little bit. Oh, maybe we should sort first. So then now I is going to be less than j after. Yeah, yeah, and this is obviously only n log n. This is n squared anyway, but that means that num sub I is going to be less, or less than num sub j, and then now we can check that num sub k is greater than num sub I and or num sub j, and I guess that's good enough. So that basically we only count it as a triplet. We're sorting the triplet in effect by having num sub I is less than num sub j is less than num sub k, right? So then here, if this is the case, then we put it into a set. Yeah, okay. Put it in a triplet, and then at the very end we just return list, turn that into a list. I think this should be good. This is n squared. There are a lot of constant stuff. Or did I not put that in a set? Whoops. There are a lot of. It's not constant, but they're constant multiplicative thing on top. Oh, do I have to sort these? Because it's giving me wrong answer. Seems like it is the right answer, but I have to. It didn't say that it has. That's weird. It didn't say that these has to be sorted, and usually when they don't, they accept any answer, and there's a they tell you how to sort it, or they just have a judge that automatically just take the difference. But okay, that's okay. I mean, it adds an additional sort, which is a little bit weird, to be honest. It may actually even make us too slow, but oh, maybe I was just confused about the wrong thing, actually. Yeah, because actually, no, I was wrong. I was looking at, I didn't look at this one, the one with all the zeros. So why am I wrong there? Oh, because this could be equal. Okay, so now this should be good. Okay. Whoops. So I was wrong about the sorting. I was just looking at the wrong. Well, good thing we have this test in there, because otherwise I'm just going to be wrong. Okay. Let's also put in all the other example cases as well. Let's run real quick. Yeah, and we should be good. If I was a little bit less lazy, I would just run a test for 3,000 numbers and kind of see the running time on that. But I think let's just let's just submit. I did run into time limited issues previously though, apparently. So maybe we'll run into it again. The problem is that now we're oh, okay, so this is fast enough, though it is twice as slow as this one. So we are using a hash table, but there is another algorithm about it, which is the 2 pointers algorithm, which is probably faster because this basically goes through the loop twice, right? So you can say that we have k is equal to n minus 1, and then just go through it from right to left as well. But I'm a little bit lazy today, I guess. I didn't really think about it. But either way, they have the same time complexity. But here you see that just this is basically an additional loop, and that's why we're maybe twice as slow. So I have gotten worse over the years, as it turns out. So I don't know. Let's kind of take a quick look to see what I did. But this is going to be n squared because of the I loop and j loop, and the array lookup is going to be O of 1, though technically this could be O of 1 or O of n log n or log t, where t is the size of the output. But yeah. Also, technically, even though I said that, yeah, so I don't know. The size of the output is going to be n squared, so you can't really do that much faster than that. So, yeah. What did I do that's so... Oh, I remember doing it this way, because I thought this was kind of a cool way of doing it, but... because this basically... I was thinking about doing it this way, like, just now, but so basically, and there's probably a video about it, but it's the same idea except for that here it goes through all the cases, because otherwise what this allows me to do is to skip this loop, so that's probably why it's faster. What about this one? I've done it a couple of times. Oh, so this one is the one where did it like not that far apart? So this one is the one that I was saying with the 2 pointers. So I guess I did do it all in all those ways, but today I felt a little bit different than usual. But as you can see, the multiple ways of doing it, they all have the same complexity. Though that said, this is O of 1 time, O of 1 space ish. Because I say ish because of the sorting, which changes the input. So depending on how you want to say, it's O of space, while the other ones are... This is O of n for sure, though I also sort, so maybe this is just weird. But here as well, I sort and so it is going to be O of n extra space. So so quadratic time, linear space, and that's pretty much all I have for this one. Let me know what you think about the font size and stuff like that. Let me know what you think about this problem. Let me know what you think about the speed. Anyway, that's all I have for this one. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.